All right, we are starting with 5.2, number 1. So again, a lot of stuff with exponents and radicals. Try these couple problems out and see if you remember the exponent rules from Algebra 1 before you start, and then check back after you try it. All right, now that you tried it, some rules about exponents. If you have the same base, so these are both a big old 2, and they're multiplying, you can add these exponents. So 3 plus 4 would make it an exponent of 2 to the 7th. Now, if we have something like this, where we have an exponent situation inside of parentheses with an exponent on the outside of the parentheses, what you're going to do is you're going to multiply those two exponents. So 2 times 3 would make this 3 to the 6th. All right, next one, again, same basis, so big old 2's. The exponents, since it's division, you can take those and subtract them. So 9 minus 3 would make this a 2 to the 6th. And then the very last one, we kind of talked about this in the last video. When we have 1 over in something with the exponent, that is the same thing as having a negative exponent. So 2 to the negative 5th is the same thing as moving that exponent to the bottom to make it positive. All right, so let's use those rules that we just talked about. So this first example, we have the same base. So big 81s are in both of these. We're multiplying, so we can take these exponents and add them. So the 81 is going to stay the same. And I'm going to do a 5, let me get a smaller pen, a 5/6, so 81 stays the same, and we're going to do 5/6 plus a negative 1/3. Now you can type this in your calculator. If you're not sure about how to do fractions, you're more than welcome to use the calculator. You're going to type in your calculator parentheses around each fraction, so that 5/6 like this, plus, and in the next parentheses, make sure that's a negative, not a minus sign. 1 divided by the 3. So hit that in your calculator. And then it's probably going to give you a decimal. So hit math, enter, enter. So that made this an 81 to the 1/2, which is the same thing as a square root of 81. Remember we talked about moving that bottom of the fraction to the root. And when we plug either one of these in as the exponent or the root, whichever one you prefer, it should give you the answer of 9. So on all of these, we're just trying to simplify as much as we possibly can. Now, I know we could have plugged this in from the get-go into our calculator. We have such fancy calculators, but looking at example 2 with x's and y's, we need to know how to use those rules that we're talking about right now to help us out when we can't plug it in our calculator. Okay, so let's look at example 2. There's a lot more happening in example 2. The first thing I notice is this whole thing is in parentheses with an exponent outside. So I'm going to take that exponent on the outside and I'm going to multiply it times all of the exponents on the inside. So this x right here has a 1 on it. The y has an exponent of 3, and this x down here has a 1/2. So I'm going to multiply each of those times 2/3. So 1 times a 2/3 is a 2/3. So now it's an x to the 2/3. I'm going to do the exponent on the y, so 3 times 2/3. If you need to use your calculator, do so. That should give you 2. So now we have a y with an exponent of 2. And then we are going to do the 1/2 times the 2/3. Use that calculator if you need to. It should give you a 1/3. So you have an x to the 1/3. third. Now, again, we're always trying to simplify using those 4 rules that we talked about in the first one. I do see that we have an x up here and an x down here, and they're being divided. So we talked about when there's division, we can take the exponents and we can subtract them. So I'm going to do 2/3 minus a 1/3. So that's going to leave me with an x. And then when we do that subtraction, it leaves us with 1/3. So we have an x to the 1/3, and now there's nothing really left on the bottom when we subtracted those. So we get divided by 1 if we want to say, or you can just put nothing now because there's nothing really left on the bottom. And there was no y on the bottom of this, so the y squared is going to stay a y squared. And we have simplified that as much as we possibly can. All right, let's look at these ones. These are similar to what we did in the last video, where we're simplifying these as much as we can underneath the square root. Now, let's look at it. Okay, again, we're gonna break these down into parts. So each part, so the cube root of that 16, and the cube root of x to the 5th. Now, if you type in the cube root of 16, it's a decimal. So we need to do a little factor tree. You may remember doing this. We've done it before. Let's practice doing it. So to break down 16, I can break down to 2 and 8, let's say. And when I break something down, I cross it out. I can break down the 8 to 2 and 4. I can break down the 4 to 2 and 2. So I broke it down as far as I possibly could. And since I have a 3 out here, I need a group of 3 things, not 2. So I have a group of 3 2s right here. But then there was this lonesome 2 all left over that doesn't make a group of 3. So what I like to do, I'm going to put a cube root here, and whatever was a group is going to come in front. So we had a group of 2s that's going to come in front. And then we had one leftover 2, which is going to go underneath the root. Okay, now let's see if we can simplify those x's now. So again, like we did in the last one, we are going to break it down. We need 3 x's to come out. So if we have 3 x's, x to the 3rd, but if I add another 3 x's, that would be 6. That's too many. So really, I only can have 2 more in there to be 5. But, so that means that only one of those is coming out. 2 of these is left underneath. So I know that's tricky. That's a tough one. Make sure when you put something out here, you're saying it as how many groups there were. And if there's leftovers look exactly how they looked underneath. So this was a 2, it stayed a 2. This was an x squared, it stayed an x squared. But we had a group, one group of x's, so it was one group that came out front. Okay, let's practice that and see if it makes a little more sense once we do another example. Okay, so I'm going to break each of these down. We have the 81, we have the A's, and we have the B's. So we need to pull each of these out as much as we possibly can. So always check in your calculator first. Type in the 4th root of 81 and let's see what it gives us. Ooh, on this one, it gives us a nice number. So we don't even need to do a factor tree. It gave us a 3 when I did that 4th root of 81. And then I'm going to also put a radical. So if there's any leftovers, they're going to go underneath the radical. Any groups are going to go in front with this 3. Okay, let's look at the A's. All right, I have If I have 4 A's, there's 4. 4 more would be 8. So there you go, I got all 8. So I have a group and a group. So 2 groups of A's came out. All right, let's look at B's. If I do 4 B's, but if I do 4 more, then I'm at 8. So really, I can only do 1 more B to make 5. So I have 1 group of B's. So I'm going to put a 1. But then this is a leftover. It's not another group. So that is going to stay exactly as it looks underneath that root. And this is our answer. We can box both of these in. That is as much as we can possibly do. All right, let's keep practicing that. Looking at this next example, we have the 5th root of 16 times the 5th root of 8. Now this is a little different. So on this one, they're times. And if I were to break it down, I'm not going to have, I'll tell you right now, I'm not going to have 5 of anything to pull out. So when you have exactly the same roots, see how these are both 5th roots? We can put them both underneath the square root. We can put it like this. It means the exact same thing. So let's multiply those, and then maybe we can pull some stuff out. So 16 times 8 is 128. So now I'm going to break this down and see, do I have 5 of something? Now, I know this may seem crazy, but I'm going to go by 2s. I'm going to do 2 and 64. 2 and 32. 2 and 16. 2 and 8. 2 and 4. Ooh, we're almost running out of room. 2 and 2. So we broke everything down as much as we possibly could. So I need 5 to make a group. So 1, 2, 3, 4, 5 2s. So we have 5 2s in a group, and we had 2 leftover 2s. So I had 1 group of 2s that came out front, and each of these leftovers is gonna go underneath. And I'm going to multiply them when they are underneath. So really, it is a 4 underneath. All right, let's practice some more of that. We got a lot happening in this next one. Just like this one, they're the same roots, and they're being multiplied. So I'm going to put everything together underneath. So if I put it all underneath, and they're multiplying times each other, we could kind of put these x's together and the numbers together. So 4 times 32 is 128. And if I have 4 x's here and 4 x's here, that's really 8 x's that I have. And then that y to the 4th doesn't have anybody else to go with, so it's going to stay. So I'm going to break down each of these individually. And see what we can pull out. Now, if I do the cube root of 128, it is not possible. It gives me a decimal. I mean, it's possible, but it's not a nice whole number. So I'm going to break it down. I know we just did it over there, but it's the exact same number. But this time we are looking for groups of 3 numbers. So I'm just being extra at this point, really showing you what's happening. So I need 3 2s. Oop, I got 3 more, but only 1 left over this time. So when I go to write this answer, sorry, it's black now, 2 comes out. Actually, there's 2 groups, so 2 to the 2nd power. And underneath, that leftover is going to stay just a 2. All right, let's look at the x's, and then we'll simplify it anymore if we can. X We're doing 3 now, so 3 x's. 3 more would be 6. If I did 3 more, it would be 9. So I only want to do 2 more. So I have 2 groups of x's, so x squared, 2 groups. And then the leftover stays exactly the same underneath the square root. All right, let's do the y's. Oops. I need 3 y's. If I did 3 more, I would be up to 6. So really, I only can add 1 more. So I only have 1 group of 3's that's going to come out front. So 1 group. And then the leftover stays the same in there. Now, the one other thing I would say you could do on this to make it look a little nicer, we do know right here that 2 squared is 4. So I would write it as 4 squared, I mean not 4 squared, 4 x squared y 2x squared. So, and you really don't have to put those exponents of 1, just being a little more clean with our writing of our answer. But there you go. That is the final answer. You can do the 5.2 worksheet number 1 to practice problems just like this.